In this lesson, we're going to connect our agents with lines, and in order to do that, we need a bit more math. We're going to revisit a familiar formula to find the distance between them, the Pythagoras theorem.
We're going to need a nested for loop. You might remember we wrote one in our first sketch. It means one for loop inside another. For I equals 0, I smaller than agents.length, and then inside this first loop we want to store agent as a variable. So agent equals to agents square brackets I. Then the second loop, using j as an index, and we want to store the agent here as a variable as well. We're going to call it other equals to agents j. So for each agent we go over every other agent. Now to draw the line we need to use two methods, move to and line to. First we start a new path, context.beginPath. Then we move our pen to the beginning of the line with context move to. And it's going to be agent.pos.x and agent.pos.y. Then we need context.line to and pass the end of the line, which is going to be other.pos.x and other.pos.y. And then context.stroke. At the moment we have 40 agents, so this means 40 times 40, which is 1600 iterations on every frame. This is fine, the computer can do it, but it is a bit wasteful because we're checking each pair of agents twice. For example, when I is 0, we go over j 0, 1, 2, 3, etc. When I is 1, we go again over 0, 1, 2, 3. So considering just the pair 0, 1, we're drawing two lines on top of each other, one from 0 to 1 and another from 1 to 0. And we're also checking 0 against 0 and 1 against 1, which is unnecessary. We can improve on this with a very simple change. For j, instead of starting at 0, it could start at I plus 1. So now when I is 0, j is going to be 1. By the time we get to say 38, j is going to be 39, and this second loop is only going to run once, because every other pair of agents would have been already checked at that point. With this simple change, the number of iterations on every frame went from 1600 down to 780. That's a good performance improvement. Now it's time to improve the visuals. This is a bit too intense for my taste. I want to draw the lines between the agents which are close to each other, not between all of them. For that, we need a bit of math. Pythagorean theorem. The name is complicated, but the formula is simple. Say we have 2 points on a 2D plane. First we find the distance between them in the x-axis. Let's call it dx. Then we find the distance in the y-axis and call it dy. That gives us a right triangle, and what we want to find is the hypotenuse. Pythagoras tells us that this will be the square root of the sum of the squares of the sides. Let's use that in our sketch. We can add it as a method of our vector class, called getDistance. And we pass in the other vector. I'll call it v. dx will be this.x minus v.x. dy will be this.y minus v.y. And the actual distance, which is what we want to return, will be math.square root dx times dx plus dy times dy. Now back into our nested loop, we can create a new variable called dist and get the distance between agent.pos and other.pos. Now that we have the distance, we can say that we only want to draw the line if dist is smaller than some number, say 200. Or we can do the opposite and say that if dist is bigger than 200, then don't bother with the rest of the code inside the loop. Just continue. The continue instruction says go to the next iteration of the loop, so everything after continue is ignored. This is already looking much better, but there's still one more thing that I want to do with it, which is to change the line width based on the distance. I want the lines to be thick when agents are close and get thinner and thinner as they drift apart. For this we can use another handy utils function called mapRange. This expects an input range and an output range, and it maps the value between the two. So once again, let's import the math module from Canvas Sketch util. And then we can set the line width based on the distance. From a range between 0 and 200, when distance is 0, we want the line to be 12. When it's 200, we want it to be 1. And there we go.
I already showed you how to export sketches as images, but this time our sketch is moving, so we need to export it as a video. And this is exactly what I'm going to teach you in the next lesson.